So, ray of red light incident on a semicircular block of glass at the midpoint XY shown. Refractive index of the block is 1.5 for red light. Calculate the angle shown in the diagram. So the first thing you need to notice is that there are two angles given. That's because that's designed to confuse. Remember that all angles are measured from the normal. So this is your angle here. That's your angle of incidence, or angle 1, in your equation that we're about to do. So n is equal to sine theta 1 over sine theta 2. So that's 1.5 being equal to sine theta 1, which is our least dense material, which is air in this case, so that's sine 50, not sine 40, and that's over sine theta 2. If you solve for theta 2, you get 30.7 degrees. Of course, make sure that you check that that's less than that. It should always be less than that because it bends down towards the normal when it's slowing down as it enters the more dense material. B, the wavelength of red light in the glass. In the glass is very important. It's 420 nanometers. Calculate the wavelength of light in air. So n is also equal to the ratio of the wavelengths to each other, where wavelength 1 is the wavelength in air and wavelength 2 is the wavelength in the more dense medium. So if its wavelength in glass is 420, then that goes on the bottom. So it's 420 nanometers, or 420 times 10 to the negative 9. Solve for lambda 1, you'll get 6.3 times 10 to the negative 7 meters, or 630 nanometers is equally acceptable. C, again, is quite common for that to be the last question, changing the colour of the light. Explain why the path taken by the blue light in the block is different to that taken by the red light. It's because blue light refracts more, so it bends more. The reason that blue light refracts more is because blue light has a greater refractive index. Because it has a greater refractive index. Done.